Bismillah ar-Rahman ar-Rahim. Hello my dear students, how are you? I hope you are fine. Today inshallah we will talk about Mathematics of Finance part 2, which is dealing with the compound interest, and we will start with the first chapter under the title of the future and present value at compound interest. Problem number 9. What will be the future value of $20,000 invested for 7 years at 8% converted quarterly? So in this example, we need to calculate the future value. It means we need to calculate the amount for the principal or the present value of $20,000. We will substituting for J equal 8% and M equal 4, so I, periodic interest rate, will be equal J over M equal 2%, and N will be equal 7 times 4 equal 28 periods. The time diagram shows that there are 7 years, and for every year there are 4 periods. So the interest will be added 4 times in every year. And to calculate the future value, we will use the formula of FV equal PV times 1 plus I to power N. FV, the amount or the future value. PV, present value or the principal. And I, the periodic interest rate. And N, number of periodic periods all over the time. And for PV equal $20,000 and I equal 2% and N equal 28, so the amount or the future value will be equal 34,820. Note that FV must be greater than PV. Problem number 10. A savings and a loan association pays 6% compounded quarterly on a savings account. A man puts $15,000 into an account on February 3, 2010. Find the amount in his account and the compound interest on August 3, 2030. In this example, we will substituting for J equal 6%, M will be equal 4, and I will be equal 6% over 4, which is equal 1.5%. And to get N, we must calculate the total time. So, August 3, 2013 minus February 3, 2010. So the total time, 3 years, 6 months. So N will be equal 3 times 4 plus 6 over 3, which is equal 14 periods. This is the time diagram. The future value, FV equal PV times 1 plus I to power N. For PV equal $15,000 and for I equal 1.5% and N equal 14, so the future value or the amount equal 18,476. And for the interest, And for the interest, we can calculate it by two types or by two ways. The first way, we know that I equal the amount minus the principal. I equal the future value minus the present value. So I will be equal 18,476 minus 15,000. So I will be equal 3,476. The other solution, from the formula I equal FV minus BV, we will substituting for FV by BV times 1 plus I to power n. By taking BV as a common factor, so the compound interest equal BV times 1 plus I to power n minus 1. So I will be equal 3,476. The same result as the first way. We will stop here. See you next time and thank you. To finance the college tuition of his daughter, a man opened a saving account with $20,000 in his bank, paying 6.5% compounded semi-annually for a period of 12 years. After 5 years, he had to withdraw $3,000. What amount will be in the account at the end of the original 12 years period? This problem can be solved with two ways. The first way is the following. Look at the time diagram. He will start with a principal of $20,000. After 5 years, he will withdraw $3,000. So he can get the amount after 5 years. Then withdraw $3,000 to get the balance. Then the balance consider as a principal of the next period. So we will get the amount of the balance for the other 7 years. We know that the nominal rate is 6.5%, and in this example it's compounded semi-annually, so M will be equal to, and from the formula of I equal J over M, so I will be equal 3.25%. There are two N for this example. The first N is for the first 5 years, and N2 will be to the other 7 years. We know that it is converted semi-annually, so 5 times 2 will be equal 10 periods. Also, N2 will be equal 7 times 2 equal 14 periods. We will use the formula of the amount. The future value will be equal the present value times 1 plus I to power n. At the start, we will get the future value after 5 years. So BV equal $20,000 times 1 plus 3.25% all to power 10. So the future value will be equal 27,537. The balance after withdrawal of $3,000 will be equal the amount minus $3,000, which is equal 24,537. Then we will get the amount of his balance after 7 years. So the future value will be equal BV times 1 plus I to power n. So FV equal 38,397. The next example, problem number 12. What is the present value of $40,000 due in 7 years if money is worth 11% compounded semi-annually? In this example, the nominal rate equal 11%. It's converted semi-annually, so m equal 2 and I will be equal J over m, which is equal 5.5%. The time here is 7 years, so n will be equal 740 times t times 2, which is equal 14. N equal 7 years times 2, because of it is semi-annually, equal 14. Look at the time diagram. We need to calculate the present value. We will use the formula of BV equal FV times 1 plus I to power minus n. So BV equal 18,902. Problem number 13. If an investment can earn 12% compounded monthly, what amount must you invest now in order to accumulate $60,000 after 3 years? In this example, the nominal rate equal 12% and the future value equal $60,000. The total time equal 3 years. So n will be equal 3 times 12 because it compounded monthly. 3 times 12 equal 36 periods. And because it compounded monthly, m will be equal 12 and I will be equal 12% over 12, which is equal 1%. The answer, by substituting j equal 12, m equal 12, j equal 12%, I will be equal 1% and n equal 36. We know that in the time diagram, the future value equal $60,000. We need to calculate the present value. From the formula, BV equal FV times 1 plus I to power minus n. The present value will be equal 41,935.
Thank you for watching. For any question, leave your comment at the bottom of the video and I'll try to answer it next time.